It always has this. I never know when it actually starts. Hello and welcome to wasmCloud's version of Turkey Day, day before Thanksgiving in the US. And so it's November 26th, and I'm excited to have everybody here. We have a very lightweight agenda, although I actually realized I do have a demo to show, which I'll run through. But before I do that, I wanted to show our Doc of the Week change made by Eric. I'm just going to share my whole desktop over here. Eric, for wasmCloud v2. And no, we agreed last week to do a dot plus here. I haven't made that change in the docs yet because we're technically on RC2, about to cut RC3, but we're going to only keep one version of the next version of the docs. Eric created this overview section, which includes a lot of the new types that we're talking about here on the goals of v2, how plugins work, what the interfaces are, how transports work, how you use like wash to be able to do your OCI packages, and probably something that a lot of people were asking about in our last community call as a request. Eric put this together for talking about how to migrate from v1 to v2, etc. So got a lot of good information here. Now this is, notice that I'm doing it off of a preview. So this is in review right now. Eric is already on holiday, but we'll look to get this merged when we get back. And so the pull request here is this one. So if folks want to comment, ask for more things they want to see, etc., please jump on there and give us feedback. Any questions on that topic? Ooh, I see chat stuff. Let me see. Oh yeah, thank you. Thank you, Masood. Yeah, the American version, but I hope other people enjoyed Canadian version. What was that, last month? Okay. So I want to show you something else that we got together over the past little bit. It's now hosted at the Bytecode Alliance. I initially started it in my own personal repo, and then I moved it over yesterday. But that is a sample for building with wasi-HTTP and doing C++ style bindings. So not just C style, but actually bindings that use modern C++. And you can make something really ergonomic and nice with it. So let me show you what that looks like. Server CPP is basically our main function here, and it has a top level handle method. It takes in that query, parses it. We're using auto and basically all of the good things that you want to see with a modern C++. We're also doing it via streams and then sending our response back. There's a little bit here where you've got to set it up in the right way for doing exports, building with WebAssembly, but it's I think it's pretty clean. Over here, I ran make release. And I print out the size here, so it's 67 kilobytes, which is pretty tiny. I like it. I like seeing WebAssembly that's just in kilobytes. And if I want to actually serve it, I'll do make serve. I'm going to run this on Wasmtime. And so if I do hello, it gives me a hello world response. If I do echo, and then I say echo something, or hey, wasmCloud, we get an echo back. So it's pretty simple. The reason why it's cool and new and worth showing off is that this is all actually only available starting in this release, 48.1. And I took all of Chris Pettig's awesome foundation for being able to support C++ and then expanded it out to support basically every case. And so now it's feature complete for, yes, it is direct support for C++. I'll give you some more details too if you're into that. In the WebAssembly space, usually all my rustations and a lot of people that are in the call are usually just mostly rustations fall asleep on me when I talk about C and C++. But it's actually C and C++ have had amazing support for WebAssembly for a long time. And there's some pretty cool enhancements that are coming down the pipe right now. And I was excited about it, so I wanted to go ahead and start taking advantage of it. But there were a number of WIT use cases that weren't handled when I started working on this. and now they are all handled. The only things that are missing that are still on this list here after 48.1 was released is WASI P3 stuff. So I haven't taken on implementing WASI P3, but WASI P2 is now feature complete. And yeah, you just have to use the latest version of WIP Bindgen to get advantage of that. I also, for P3, I did come up with a sketch for how I think it should work. And I've been hashing it out with Christoph, who runs a lot of the AutoZar C++ project, and also with Cy Brand, who is like pretty awesome engineer in the C++ space. I'm really excited that they're working on WebAssembly, wasi-SDK, wasi-libc now, and we rely actually on this library that they created for us to be able to do expected. So we were able to backport even some things from C++ 23 so that we've all decided our baseline is C++ 20, which is very beautiful modern C++. And what that gives you is coroutine support. And coroutines have this really great alignment with this new feature that's coming down from the component model, which is called cooperative threads, which will basically mean that I can I can do real threading, like actually pthread style threading. Actually, person I was just talking about, Cy. Cy is working on this in wasi-libc. Let me show you a little bit of this. Uh, I bet I could, Frank. I bet I could. I'm getting pretty far. And it's actually something I've tried before. And I was able to get something that could run in a browser back in the day. This was about 6 or 7 years ago with mscripten. Now, I'm 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 like starting to like slowly unwrap this whole big onion that is how all of the like SDKs come together. But WASI SDK is obviously designed more for WASI. There's this other SDK called mscripten, and mscripten started with basically targeting C and C++ projects. And Scripten, to begin with, targeted only web environments. And so it adds a lot of JavaScript glue to make things just work in a web world. So they've got their own emulator for pthreads that uses web workers. They have an in-memory file system that they implement stuff on top of. And it's good. I mean, it's actually great. I mean, a ton of sites are built on top of mscripten. Autodesk, Adobe, basically everybody. And it's now largely maintained by Googlers now. But originally actually started at Mozilla, which I think is fun. It's a fun fact. So wasi-libc here is the guts of how we support a lot of things, even in the Rust side of the world, actually depends on this project here, wasi-libc, and it's bundled into the WASI SDK. Now, wasi-libc, we've been growing rapidly right now so that we can support some of these new component model features. In the next version of the component model, we'll have cooperative threads, which will allow us to do both threading, but also this type of green threading and coroutine, goroutine if you're in Go, essentially a more modern way of creating these lightweight threads on top of this cooperative thread model. So rolling back to what I was talking about here, coroutines are going to be a lot more lightweight, probably a much better interface for bindings. Now, I think inside the component, when I compile something like Envoy, I would use threads there on the inside of the component. But the boundary for what I hand to other people, I want it to be this lightweight async thing, and where they can call out and call back into me. So I'm getting really excited about the C++ work that's happening here. There's a lot going on in the space. I think the top 3 big ticket items that are about to land. Threading, about to land, maybe a month and a half away, but that's like really soon. Cooperative threads, exception handling. So we've landed exception handling fully inside Wasmtime. Now it's about getting the producer toolchain inside wasi-libc to support exception handling out of the box for C++ exceptions and set jump lump jump. Now, something else that I had done that I think might be a little bit interesting to folks is that I also was able to get abseil building out of the box with the latest and greatest. And I think actually they've got a few more for me to do here, but that's okay. I've got WASI stubs, which would allow me to build WASI out of the box today without waiting on cooperative threads. if you don't know about abseil, that's okay. It's if you're familiar with Boost, it's like basically modern Boost. And so with abseil, there's a ton of projects that build on top of it, including protobuf. So what I was able to do out of the box, once I updated abseil CPP, I actually was able to build fully. Let me pull that one up. Fully protobuf. And so I was able to run a little command here. You can make for both wasi-p1 and wasi-p2 and get, yeah, protobuf basically working. And it'll output, serialized and deserialized version of protobuf. So that was a project that before people had to come up with a lot of different ways and kind of weird custom build hacky things. And now we've been landing a lot of changes all the way upstream so people can just take it and compile it out of the box. So I see your challenge, Frank, for getting Envoy compiling to Wasm, and I think it's possible. Certainly, the best time to try it would be right after we get cooperative threads and right after we have exception handling implemented. Most things in C++ will just build, and that is really stinking cool. So that's my demo.
Uh, Bailey, that was an incredible demo. I think this is the best time when I think we've ever connected all the dots between the work around C++, coroutines, and cooperative threads. I think that was the most like salient and simple explanation we've ever done. So thank you so much for that. Talk to me a little bit more about the protobuf piece. gRPC is such a key piece of the ecosystem. How does what are the steps to really get all of this working then across components and around the ecosystem? Because that's what I think. That's my question that I would want to ask. I assume other people on the call, thumbs up. That's what's on your mind too, right?
Yeah, so a lot of people pair gRPC and protobuf together because obviously protobufs are the types that you're sending over the wire. But gRP itself is its own networking protocol, basically for sending those messages of those types. So it's important to decouple those because it's a different layers that I have to get implemented. So for the protobuf side. I guess there's only a few things that most people already are familiar with. Like most people already know that they have to run this proto-C command. That's fine. You run that locally to generate your code. But
Yeah, protop, right?
inside your application code, right, you compile something in that either knows how to serialize or deserialize those types. And that's what this project does. So just specifically speaking about protobuf type, serialization and deserialization, that's all this project does. So if you look at the source code, and both native wasi-p1 and wasi-p2 builds work with this project today. So if you wanted to grab it, just try it. It will work. And it's dead simple, right? Like I ran proto-C. I got my little stubs for what a person is, my person type. I'm able to set ID and email for that person. And then I print it out at the end. So I serialized to it and serialized back out. Dead simple, but it proves that that part of the ecosystem compiled and is working. Now, what you could imagine is taking basically what I have here, putting that behind a handler here. So in server HP CPP, instead of doing a hello world handler inside my handle, instead I would want to be able to do a gRPC handler here. But there's something else that has to change. I have to say and handle the way that I'm doing my HTTP calls to actually do gRPC instead. The body of what I'm putting in there is this. This is inside the body for that. Now, I think a lot of people stumble and some people want something like this to exist. Uh, so other folks have proposed ideas about note that this isn't implemented or a real thing, but some people have been like, hey, why don't we just have something that literally says its exact protocol and behavior as part of the definition? This didn't go forward and nobody builds on this type of thing because you don't have to do it. Actually, all you have to do is, oh yeah, I just moved this all around. This was me. I just changed that. Even I can't remember. That's gonna be a thing for a while. Okay, so inside WASI HTTP, what's important about this is that it's actually designed to be protocol agnostic. So you should be able to pass in the appropriate headers and body format and do HTTP and give enough information to your WASI HTTP server implementation to know what type of protocol it's supposed to be providing. Today, most people do gRPC with HTTP 2, which means if I pass in a header that says I'm doing basically HTTP style streaming, the TE header, and I pass that through, my HTTP server implementation should know that that's the type of protocol that I need to connect and set up. So for the most part, the answer is your all of that is not in your guest code. You obviously do the serve side of the business logic with your WASI HTTP, but it's basically just WASI HTTP streaming. And the actual interesting implementation that happens is outside of this code. It's actually in the runtime and the HTTP server side.
This is awesome. And this feels like a pretty important milestone for us in WebAssembly. So thank you for all the hard work grinding on the details here and all the collaboration. I know Sai and all the other collaborators aren't on this call, but pass along our thanks for sure. Yeah.
And then also note, Aditya has also been building out, innovating this space. And yeah, Aditya, you did the Rust version of this. Do you want to talk about that? And if you don't want to talk on the call, that's okay too.
Um, uh, yeah, sure. I haven't prepared anything. It's going to be ad hoc very
I'm gonna
much.
be honest, I didn't prepare anything that I just did. That was just off the top of my head.
Yeah, it's fine. I'll try. But yeah, so what I built was to basically make use of fuzzy HTTP. And as you said, just add the application slash gRPC header while we are making the gRPC call. And that should pretty much be it. And Tonic just takes care of the protobuf bindings. And we're basically calling a Tower service to instead override the default service that's used by Tonic and call the wasi HTTP outgoing handle. So in a way, it kind of ad hocs its way over to our HTTP server, where I've also implemented a gRPC client support directly into wasmCloud. Yeah.
Yeah, so I think we're still working on landing a number of things. Last week, Lucas demoed the HTTP, basically our ingressing story for HTTP inside the Wasm Cloud host, and we kind of rejiggered a lot of that, and now we're ready to start adding in a lot of these enhancements on top. And yeah, I think probably before the end of the year, we'll have really great gRPC support built into Wasm Cloud, which thanks to Aditya and Lucas on that work. Any questions, y'all? Obviously, we're a little content-like because Turkey Day is tomorrow.
I have a quick question, not about either C++ or gRPC, even though it's kind of related or becomes related to gRPC, and that's about version 2 and the fact that Kubernetes is the, let's say, default runtime or scheduler, if you want to call it. Not runtime in the sense of runtime, right? Running environment, I mean. So my question is about workload identities. You know, on version 1, we had talked about workload identities for a while. Colin even did the implementation, or sorry, that was Jonas that time that he did that, right? So in version 2, you know, again, because of the relationship or closer relationship with Kubernetes environment right now, would we consider workload identity to be a core feature, or we consider that to be a customization that we apply to our own, let's say, hosts when we customize them?
I see it as an external feature. We handle ingressing into components, but a lot of people have their system set up in a way that already defines their workload identity. So instead of us creating our own isolated island of how everything has to work, and then other people have to match to us. And that was one of the problems with our original POC, is that it really leaned into NATS style, basically off to be able to do all of that, and made it incompatible with what other people were already doing with MTLS and workload identity and service meshes. So essentially, the short answer is you do exactly what your service mesh does, and that's what would give you workload identity. But from our perspective, we're agnostic about how that gets implemented.
Okay, thanks.
Lucas, do you want to say that comment out loud? Or I could also say it out loud.
Oh yeah, no, sure thing. In V2 workloads, they carry the namespace from their original request. So pretty much whoever wanted to start a workload. So the key inside each host, like we keep all workloads keyed on namespace and workload name. Together with that, each workload has a workload ID. So from a scheduler's perspective, you tell something like namespace default, workload, HTTP server, and I want my identity to be X. Now the scheduler has the opportunity to go to all the hosts that will have to deal with that identity and prime that identity. Essentially tell it, hey, get ready, you're about to receive the workload default HTTP server. And after that happens, we send the workload there. So identity now becomes part of the scheduling operation even. If we know that identity cannot be assumed, impersonated in that given host, we don't even send the workload there. Where in V1, workload identity was tackled on top. So the host participated a lot in creating the identity for the component that is about to schedule. And this means the integration here for identity in workload V2 is going to be way simpler. And when we enable it, we're enabling it for components, not for the host. Like the identity of the host is not really interesting to have. Does that make sense?
Yeah, sorry. Yeah, it does. In V1, it was really the identity delegation kind of a scam.
Exactly.
Right?
Yeah. So now we're moving away from the delegation to be like a real assignment. The host doesn't need to participate in the identity of the component.
Right. And that was something that I wanted to ask you, Lucas, when you say workload, because workload right now in V2 is a loaded term, right? So when you're saying workload, you're talking about, in this context, you're talking about the individual components, or you're talking about what we define as a workload?
What we define as workloads. So the boundary that we're drawing for V2, we can think of it as the application Wasm YAML. That entire YAML gets the same boundary. So if we are telling it has a specific permission, the permission is for all the components within that boundary. And the idea here is that what you're composing with a workload now is more analogous to fulfilling a with world. So you carry your entire world. And as you need to communicate with other components, other pieces of your infrastructure, you're going to use RPC, and you're going to be explicit about those RPC calls. The interesting part here is, as workload identity comes in, it will be part of this communication, this RPC communication across workloads. Because if you use wasmCloud messaging, we know the identity of your component. We know the identity of the component you're trying to reach. And we can essentially provide ACLs at the scheduling layer. So you can imagine creating a YAML inside Kubernetes or any other schedule that looks a lot like an RBAC rule. And you say, I want to allow component workload HTTP server to talk to my payment API, which is internal.
Understand, thanks.
So that begs the question, I mean, because we're getting to RBAC security and so forth. I'm wondering, can somebody then take over some identity and use for other things? I mean, what's the control there?
Exactly. So the control here is the scheduling operation. As we tell the host, please start this workload, everything that is happening in that workload is, sorry, everything that is happening in that request pertains only to that workload. Where before, the identity was part of the host, and the host was delegating to components. Meaning, if you have a component, if you schedule a component with the same name on the same lattice, it's doing workload identity takeover. So that was the challenge with V1. We had no way to prevent components from taking over each other's names, identities, essentially. There was no unique ID involved. And now we introduced a unique workload ID for every single component. So even if your component is named HTTP server, when it goes to the host, it gets assigned a unique ID. And this can happen many times.
I think also one of the key points that Lucas is making here is that this isn't part of the host authority. Like, the host doesn't make any of these calls. All of those decisions have happened prior to it's gotten to the host. So if you have something like Spiffy Spire set up and you're doing cert termination, that you're doing that at the ingress layer before it's gotten to the host. So at your proxy. So if you're using something like Envoy, it handles multiple different certs. And you can use essentially what we're kind of conflating a little bit here, I feel like, the concept of an identity, but the unique identifier for the workload. You're able to do that at the ingress layer. And then in terms of RBAC, what Lucas is talking about here is very much, it can be Kate's RBAC, but it could be abstracted. But essentially with Kubernetes RBAC, we've got these workload types. We know exactly what they are, and once they're resolved, and where we want to deploy them and what makes them unique.
Yeah, I'm still, I say, digesting this, but just from a semantics point of view, would it make sense to call this, instead of unique identity, a unique identifier?
Yeah,
Because identity is a very
better.
loaded term from, okay, that
Yeah.
I agree.
All of these terms are so loaded, aren't they? Even component, to us, we're like, yeah, component, obviously a WebAssembly component, but to the outside world, that's not a given. Any more discussion items on that one? Okay. Alrighty. Well, I think that is all, folks. So I hope you again have a really good rest of your week. And if you are celebrating Thanksgiving, enjoy lots and lots and lots of turkey.
In my mind, Bailey, I heard that in Looney Tunes style. That's all, folks.
That's all, folks.